Hey guys, welcome back to the Prehistoric Life Podcast. And today we have a double interview. We're welcoming back Dr. Person. First time on the show, we got Michael. Would you like to introduce yourself?
Hi everyone, how you doing? My name is Michael Wallington, and I'm a student of paleontology here at the College of Charleston.
And Dr. Persons, would you like to reintroduce yourself?
Sure. Hi, I'm Dr. Scott Persons. I'm curator of the Mace Brown Museum of Natural History and a professor of paleobiology here at the College of Charleston.
So recently, y'all got back from a fossil expedition, fossil dig, fossil hunt, whatever you want to call it, in Wyoming. So for all the basic listeners that are out there, I'm calling that one person out, did y'all find any dinosaurs?
We found a lot of dinosaurs. So in addition to finding new dinosaurs, and we did find some of those, we also continued work on dinosaur discoveries from a few years past. So we're continuing to excavate a large Triceratops specimen, and we're also continuing to excavate our big nodosaur.
All right. So now that person got their answer, let's get into some more deeper stuff. So other than dinosaurs, I heard something maybe about something else while I was down there. Was there anything else?
Well, there was a bunch of other elses besides dinosaurs. So we work a microsite while we're there. So we find chunks of turtles and garfish and crocodiles. We also work a number of fossil plant sites. So we pulled out some wonderful, wonderful leaf specimens. We also brought back now into our preparation lab a fossilized palm prawn. But I think
Wow.
that something else you're referring to is the big mosasaur. So we returned to excavate more of the Pope Francis mosasaur specimen, which is at a different site than where, of course, we're finding the terrestrial dinosaur material. But out in the Pierre Shale exposure, we dug up a good portion now of a skull and a series of vertebrae from a pretty decent-sized mosasaur.
So that's always really impressive. I got my localized mosasaur here. So clearly we got a professor here and a student here that way. From like the student standpoint, from actually going out and digging and learning about this, how does that experience kind of affect you? How do you feel about that? I mean,
Is this a question for me?
yes.
All right. Well, from my experience, it affected everyone a little bit differently. Some people enjoy being out in the field a lot more than others. I personally love it. I enjoy it even when you don't find anything. It's the very fact that you're out there and you're out looking for dinosaur bones that does also make it fun. I mean, granted, there are days where it can be a little frustrated. It's like, oh, another rock. Ooh, maybe that's something. And it might be a chunk of bone that doesn't lead to anything. But overall, it's a great experience.
And then from the professor point of view, you're sitting here. I really don't know what you're out there doing. I haven't been out there yet. So you're watching all your students dig and try to find stuff and get really excited. How does that like affect you?
So our field school, and it really is a true field school. So we've got specific things we want to accomplish from the perspective of training the students on how to perform a dinosaur excavation, and from the perspective of giving them a broad experience of field work. But layered on top of that is the fact that this is really and truly an expedition that has got scientific research objectives. There's specific things we want to accomplish, specific sites that we want to go out and visit and collect data from for the purposes of eventually publishing the research in the formal literature. So there are multiple layers to it. And of course, we've got a mixture of students. We've got students like Michael who are out there who want to become career paleontologists, that they're there to learn those skills. And we've got some students that are there that are taking the course as part of a broader geologic program. Their particular interest may not be in paleontology, but they're still there to gain the field work, the field school experience.
And of course, in Wyoming, you have Lance Creek, so they might not be doing specifically Cretaceous, they might be doing something else. They might be doing human. They might be doing mammal. They might be international. I mean,
as far as their broader interests go, yeah. Of course, our work is centered in the Lance Formation, which means that we're there at the very, very end of the age of dinosaurs. That's Hell Creek equivalent. And all the field projects that we're doing there either relate to the Lance Formation or to our marine site over in the Pierre Shale, which is also late Cretaceous, but a few million years further back in time.
so could you kind of go on what works about how there's a terrestrial and then I guess aquatic dig site? Well,
Sure. So the story that we're exploring at the very end of the Cretaceous is one of a falling seaway. So the Western Interior Sea that cut North America into, and Michael did a small project and helped to put together a museum display on that story in the Mace Brown Museum. You've got high sea levels. Back when our Pierre Shale deposit is being laid down. So the way you're able to walk across a prehistoric seafloor at high elevations in Wyoming is that sea level was really, really high during the late Cretaceous because of prehistoric global warming. There are no polar ice caps. And the interior of North America is much lower down. And then what happens is you've got this oceanic plate that's colliding with the western coast of North America. And as that happens, it's pushing up the Rocky Mountains, but it's also causing an overall uplift of the American West. And as that happens, it drains the seaway. So where once you had a thriving marine community filled with ammonoids and plesiosaurs and mosasaurs and pterosaurs overhead, that begins to retreat. And then above that, we get our Fox Hills Formation, which is some barrier islands. And then above that, then we get into the terrestrial environment of the Lance. And even though it's terrestrial, it's still very wet. It's a swampy, marshy environment, a lot like what we currently have here, just slightly inland in Charleston.
so that marsh would also raise suspicions about maybe animals, how they live there, how it affected them.
Absolutely. So one of our grad students, Clell, is doing some isotope work on analyses of teeth collected from one of our microsites. And one of the things he's hoping to look at is trying to parse out which of our big herbivorous dinosaurs was most at home in wet nearshore environments and which ones may have preferred to browse and graze in more upland environments.
And I guess more, just speaking out, more duck-billed like creatures would tend to be more aquatic, maybe.
Well, as the name duckbill
Not
would seem to
necessarily.
sort of imply that, but that's exactly right. Yeah, our ceratopsians seem to be far more at home in a wet, marshy environment. They've got bigger, broad-spreading toes, and Triceratops is our number one dinosaur to find there. We've got lots and lots of Triceratops skeletons, and as Michael can tell you, we may have other Triceratops fossils too.
Other Triceratops fossils as in
we
new
do, yeah.
species, or
No, other kinds of fossils. Go ahead, Mike.
No, I don't think. Yeah, what we may have is a possible Triceratops trackway that we discovered last year, just sort of eroding out of the hillside. There are certain layers of ironstone that preserve fossil tracks really, really well. Also, sorry, my screen has been frozen for the last couple of minutes. Am I still
we can still
appearing
hear you.
normally on your end as well, guys?
You look as normal as ever.
Okay,
Michael.
but my screen is frozen.
Yeah, you're good.
Right? Okay,
Yes,
cool.
yeah.
I'm working with a blank screen, so. But we have this layer of mudstone, or what would have been mud in life, and along a riverbank, something like that, you have an animal stepping through it, and it could be in like a floodplain of a riverbed, And when that river floods, you're going to get more sediment infilling the impression left behind by that animal. What we think we have here is a Triceratops possibly walking through some sort of floodplain area, very muddy place, and that immediately filled up, or very quickly filled up, I should say, leaving a good few tracks for us to follow where it was moving and how fast it was going and how much it may have weighed.
And you can tell that based on I guess size would be a bit easier than some things because you just look how far the tracks are.
Yes,
if you want to estimate
layer, I think that might be a little. Thank you. With this layer, I think it might be a little bit difficult just because there are some areas where the tracks have gone straight through the actual layer that they were left on or where they were impressed in. So, you can't just go in and say, oh, it sank this far deep in, at least with some of them. So I think that'll be a tricky thing to do.
And then weight, you just kind of look how far down it is, give or take.
Yeah.
Well, if you want to do a size estimation
Yeah,
for
we
the
can
animal,
roughly estimate that. But
now Michael's frozen.
Yeah.
Tell you what, normally.
All right, sorry for that. We had some technical difficulties. I think we got it all worked out, hopefully. So we're talking about size estimates for how you would tell size estimates for tracks.
Yes, and I believe the ball was in your court, Dr. Persons.
Sure. So the point I was just making is that if you want to estimate the size of a dinosaur from its track, the depth of the print, as Michael was explaining, can be very deceptive because our animal may have actually stepped through or erosion may have occurred afterwards, increasing the apparent depth of some of our tracks. There's sort of like potholes in the Wyoming desert. Erosion and other factors can continue to exaggerate them. But what you want to look at to get a size of an animal, if you know what kind of critter you're dealing with, is the proportions of the track itself as it relates to the width or the length of the footprint that made it. You can then take that and compare it to the known foot size of your animals and scale it up accordingly. And in our case, too, because we got an entire trackway, a whole series of footprints, you can look at the stride length of the animal. You can figure out how far apart its feet were. And that can give you a sense for how big of an animal roughly you're dealing with. And in the case of Michael's Churchill tracks, it looks like, if we're right, it looks like you're dealing with a pretty good size adult ceratopsian, Triceratops or Torosaurus, it's hard to say. But we imagine an animal on the scale of multiple tons.
Yeah, these are big tracks. So you can sit in them quite comfortably.
Wow. So hopefully it'll actually lead you to the animal. Doubtful. I bet that rarely happens, but
there is I remember. Sorry.
Go ahead, Mike. Go ahead. Which one are you thinking of?
I remember thinking, I've heard it said before that the places where you find tracks, you're most often not going to find body fossils themselves.
That's exactly right. As a matter of fact, our Glen Rock site breaks conventional wisdom as it relates to dinosaur tracks and body fossils. Because for a long time, and this is true in most places, the rule is you never find the skeletons of the same animals for which you've got tracks. There just sort of seems to be this big disconnect. And it's partially because the kind of microhabitats that wind up preserving tracks are different from the microhabitats that preserve body fossils. But in our case, we have got what we think are Triceratops or Torosaurus footprints within shouting distance of a Triceratops skeletal quarry.
Huh.
Mm-hmm.
So,
but if you meant, could we follow the tracks and then see where the dinosaur died? No, that doesn't really happen. The only sort of instances like that I know of are there are a couple of cases
very
of
sudden.
horseshoe crabs, where we've got the body fossil of the horseshoe crab and then also a long trail of tracks leading up to it.
A few trilobites as well, I think.
Mm-hmm. Mm-hmm.
Those are roughly in the same court there, so I could. So, but so it's a very unique thing to have like actual Triceratops body fossils that close to tracks.
It's a unique thing to have Triceratops tracks at all.
Exactly.
And you were saying that it's not usual to find tracks and body fossils together. Is that like an always thing, or is that like a on average most of the time, 9 times out of 10?
No, that's a typical thing. And it isn't necessarily that you don't find tracks in the same area that you find body fossils, although that is broadly true. It's more that there's often a discrepancy between the kinds of species of animals that are recorded at track sites versus what winds up being preserved in the body fossil, the bone, the skeletal fossil record.
And that tends to do, I mean, also for the obvious side that if it's trackways, the animal's probably not there anymore. Probably means it's leaving.
Mm-hmm.
So there's a very. We also don't know what all is going on. I mean, so who knows what all we've walked over? I mean,
That's a question that I find myself constantly asking when we're out in the field is how many little dinosaur bones have I walked over that I've completely missed?
because I mean, especially out there, every other acre has God knows what on it.
Oh, we've undoubtedly traipsed across hundreds of dinosaur skeletons. And if we had X-ray vision, we'd know where to dig. But since we don't, we're forced to focus only on the specimens that are exposed on the surface, that we see a little hint of the skeleton beginning to erode out of the hillsides, where we see that we then start to dig in.
So you mentioned also the nodosaur that you were working on.
Mm-hmm.
What other kind of things have you found for that?
You mean what elements of the nodosaur have we found, or what fossil record do we have of nodosaurs besides the particular quarry that we're at?
Of that specific nodosaur, did you all find anything more of it, or?
Yeah, so our nodosaur is predominantly represented by pieces of bony armor, of the osteoderms themselves. But we have found ribs from our nodosaur. We've found some teeth of our nodosaur. And most exciting of all, we've got a portion of the hip of our nodosaur.
Ooh. And I guess those are still, well, they're probably not at Charleston. They're probably still out there somewhere.
Oh, no, actually, I've got the hip here in my office.
Just gonna casually walk out with a dinosaur hip. Okay.
Well, it's his one of his primary areas of research right now.
Yeah, so this is the element that we're really, really excited about.
Oh, yeah.
This is the issue. I mean, you remember me showing you this one, I think, in our last podcast interview, right? This is the one that's got the Tyrannosaur bite mark on it. So this is the same animal we're working on.
And I forgot that it was a hip. I'm gonna be honest. I thought it was like a piece of armor. I just forgot wrong.
Well, we've got some of the armor back here too, and we brought back more chunks of the armor to work on in the Mace Brown Museum's preparation laboratory.
And of course, that being in, what is that, Ornithischian? The Ornithischian family?
Thyreophorans specifically.
So, I mean, because I also know that there's, what was it, sauropods are kind of being changed around in the between Ornithischians and Sarnosuchians, or
Oh, the great shakeup of the dinosaur family tree that occurred a few years back. Yeah, for a long time, we liked to lump theropods and sauropodomorphs, the long-necked dinosaurs, and then the carnivorous dinosaurs, together on one branch. And then we had the ornithischians, the beaked herbivorous dinosaurs, or the quote bird-hipped dinosaurs, as separate. So saying that theropods and sauropodomorphs were more closely related to each other than either were to the ornithischians. And we're no longer, I don't think anyone is strongly convinced of what that exact relationship ought to be, which of the three groups is really and truly more closely related to the other. So for right now, our three major branches of the dinosaur family tree are a polytomy. It's an unresolved relationship. We don't know which one is more closely related to the other.
It's something that I've drew up a while back, then forgot about, then found, then that's not the right thing. Ah, dang it. Struggling here. This kind of shows the how the clades are kind of organized throughout. What am I doing here? There we go. Maybe? Nope. All right, didn't add it.
Oh,
there we go. You kind of got more of the clades and how they've changed.
Yeah, so the different dinosaur clades, it looks like, if I'm interpreting the diagram right, in what, for me at least, looks to be the upper left-hand corner.
The traditional.
There we go. Yeah, there we go. That's the traditional or the old school view of the ornithischians and then sauropods and theropods together in the saurischians. And then you've illustrated the other competing hypotheses. And we really don't have a very strong sense for which of those is correct. So for now, I'm at least just happy acknowledging the three major branches of the dinosaur.
That's the main thing. And that is pretty difficult for me because for all of you who have been watching the show and follow me on Instagram and all that, you know about the whole, what was that, dinosaur family tree that I've been working on. That's a nightmare and a half sometimes. Taking a little break from it because I was losing my mind.
Yeah, taxonomy will do that to you, especially prehistoric taxonomy.
Because you get one species and you only have like 2 or 3 bones from it, and they're like, we don't really know what it belongs to, so we're just gonna clump it in here.
Yep, a wastebasket taxon, yeah.
So, and then you have like 80 different scientists trying to say 14 different things, 14 different theories that you're trying to.
Well, there are lots and lots of relationships on the dinosaur family tree that hinge on interpretations of a few key specimens, many of which, as you know, are known from very scant remains. Plenty of dinosaur species are represented only by a handful of bones, and some of those are actually pretty important specimens, especially when you're talking about really old dinosaurs or proto-dinosaurs.
And especially smaller creatures in the environment, because the tiny little lizard probably isn't going to preserve as well as the grand T-Rex. I mean,
yeah, and that's one of the reasons too why there's a discrepancy often in the preservation of footprints and skeletal material. Often, not always, but often it's the case that a track record can do a better job of preserving the diversity of small-bodied or medium-bodied animals, whereas the skeletal record often has a very strong bias towards the large-bodied specimens. Now, that's also in part because there's a bias towards stumbling across larger bones from larger critters. One of the things I think that the dinosaur track record has been telling us for several years now is that we have really been underestimating the diversity of small and medium-sized dinosaurs. That if you could travel back to the Mesozoic, although you'd certainly see the really, really big ones, you'd also be very much so impressed by the diversity of small and medium critters that are just not showing up as well in the skeletal record.
Well, that would also be the thing. I mean, there wouldn't be as many T-Rex as there is like other smaller, medium-sized things, because then you would have a horrible ecosystem. The same reason why there isn't one fox per each rabbit. I mean, there's one fox for like 10 rabbits. You have to have balance in the ecosystem. So some of those smaller creatures that might be easier prey or whatever you want to say for bigger theropods, or there would be more of them.
There is also the fact that when you're smaller, you're working on a almost completely different ecological scale. Like, for example, the first thing that comes to mind, entomology is a passion of mine, but it's not something I pursue professionally. But like, you have thousands upon thousands of different species of insects. Like beetles alone are the most diverse group of animals on Earth that I can think of. And they're working at such a small scale that their ecosystem may very well just be someone's backyard. Maybe a little bit bigger than that, like an acre, 2 or 3 acres. And they're able to evolve and diversify much more rapidly, not just because they have very short lifespans and they're able to reproduce very, very quickly, but also they're working at such that small scale that just there's more space for them to sort of adapt and evolve to new and different places.
And the consequence of that is when we're talking about the diversity of small-bodied critters, we're not just talking about the numbers, that is how many individuals there are, but we're also talking about the number of species, because not only can the ecosystem support more individuals of a small form, but also small forms can become more easily specialized than large form can because of their reduced energy requirements.
And even within like a species, we've just been saying like Triceratops, but then there's like 2 types of Triceratops. So you can even break down even further than that. So if you get one generic, smaller, maybe even saying theropod creature, I mean, that already specializes it more. And then it up even more into how many ever species to fit whatever niche it needs to. I mean, the dinosaurs are just a very unique evolutionary marvel. I mean,
and our microsites record many teeth from different genera of raptor dinosaurs, some of which we are still lacking good skeletal material other than the teeth for them.
Do we have any raptor fossils at all at the Paleon?
We do. We've got a few of them. We've got one possible humerus. We've got some of the caudal vertebrae from a dromaeosaur, which are very distinctive because of the long caudal rods to them. But we don't have very much. There really, really is a strong bias against the small and medium-sized animals being preserved. If you look at our microsites, for instance, we've got lots of teeth from Thescelosaurus, a small-bodied ornithischian herbivore, but we only have one partial skeleton. There's a big disconnect there.
And that all dwindles down to preservation bias. I mean, the same reason that chicken bones are weaker than a cow bone. I mean, and especially with like a raptor or something, they're probably have more chicken-like bones, so
sure,
it probably doesn't preserve as easily. And like a size estimate for that dromaeosaur, or is that just we only know it's a dromaeosaur?
Well, again, we've got different dromaeosaurs that are present. There have been some teeth found in the Glen Rock exposure that look to be on a scale consistent with an animal like Dakota raptor, and then there are many others that are much smaller animal. And then besides dromaeosaurs, we've also got troodontids.
And especially pterosaurs. Have y'all found any pterosaurs or anything like that?
Not at the Lance itself, no.
And I mean, is that due to there probably were less of them there, or just
No. This is also another issue of preservation bias. Simply because most pterosaurs that we know of are all coming from coastal areas. The only exception that I can think of is Rhamphorhynchus off the top of my head, and even then, that was found. Sorry.
Rhamphorhynchus is still preserved in a marine/lake environment, but animals like Quetzalcoatlus is suspected to be a more terrestrial, more inland pterosaur. But of course, that's an extremely large one. But yeah, there's a huge bias in the pterosaur fossil record towards marine specimens. Now, at our Pierre Shale site, same place where we're pulling out the mosasaur, we have absolutely found pterosaur material there.
And why do you think it is more of a bias towards marine sites?
Oh, because when you die in the Pierre Shale, when you die in the Western Interior Seaway and you sink down, you wind up being in a low oxygen and anoxic environment, and you can get buried very, very quickly there in really, really fine marine shales, which can do a much better job of preserving smaller elements. Whereas if you die in a terrestrial setting, in an environment where the major influx of sedimentation is the result of a river system, something like that, it will just smash and break apart the extremely, extremely delicate, thin-walled bones of pterosaurs, just tear them to pieces. Now, having said that, there is a debate going on right now about whether or not pterosaur diversity was strongly waning as you get towards the end of the Cretaceous. And there are two interpretations. One is that, yeah, pterosaurs were being reduced in numbers, maybe due to competition with more and more sophisticated avian species, competition with birds, or alternatively, no, that's just a result of preservation bias because you've lost environments like the Western Interior Seaway. That if you look at where we think we've got all this great diversity of pterosaurs, that's almost all associated with marine habitat. And maybe if you correct for that and correct for even terrestrial forms that we do know about that are preserved in exceptional like asphalt deposits and things like that, maybe then there's no reason whatsoever to think that pterosaur diversity was strongly waning. I'm inclined to blame potential preservation bias for that distinction, but
because didn't you say that the only like more offshoot pterosaur was like Quetzalcoatl, where it wasn't quite in an aquatic biome? But
there's certainly an example of a pterosaur that is found in more terrestrial.
And you look at the size of it, and it's like, okay, yeah, you might as well have just found a Utah raptor or something. I mean,
it's a flying giraffe.
Yeah. So it's like, okay, no wonder it preserved pretty well.
Yes, the counter argument to that is to say, well, wait a second. The reason that you're finding Quetzalcoatlus so late into the Cretaceous is because there were no really big birds, and the birds that were competing with pterosaurs, they've winnowed out all the small-bodied pterosaurs. Yeah. So the only thing that's left, the only thing you could find, would be the big ones. That's the counter argument.
And I mean, going off of that, a lot of people think they're like, pterosaurs. You got like the famous pterodactyl, this big flying creature, the giant shark beak but a lot of them aren't like that. A lot of them are like bat-sized. I mean,
yeah, Pterodactylus itself is not a particularly large pterosaur.
I mean, of course, you're saying that like only finding bigger ones, because I don't see a bald eagle taking out a Quetzalcoatl in this day or this hour. So
sure, of course, it wouldn't be a matter of taking it out. I'm not imagining evolutionary dogfights between pterosaurs and birds. It would be a matter of ecological competition.
Yeah, the question that I have, because this is the first time, not the first time, but first time I've really heard that explanation that birds may have already been dominating those niches. To me, that just sounds less likely just coming from a timeline perspective, because you have pterosaurs evolving way before dinosaurs ever took to the air. So I would assume that the niches that birds would have taken over already were occupied by pterosaurs. And of course, maybe there's an argument to be made that you've got hot-blooded dinosaurs flying around in the air, able to outcompete with pterosaurs. But that to me just doesn't seem likely.
No, and I see no reason to think pterosaurs were not as endothermic as dinosaurs or birds would be. Nevertheless, it is the case that prior to the evolution of birds, you would imagine pterosaurs were filling all the aerial ecological niches that they could. And the fact is, you do see birds showing up. So presumably, those birds are invading some ecological roles that pterosaurs had been filling. Now, maybe that's not quite right. Maybe birds are able to do some things that pterosaurs couldn't. Maybe, for example, birds are really good at being both in the air and on the ground, because the pterosaur's wing membrane attaches to the legs. There's debate about how far down it attaches and whether or not that really makes a big difference to its ability to move around on the ground. But you might make the argument that because birds can sort of do both really well, that may have given them an edge in those sort of only a little bit aerial, or in an instance where you need to sort of split the difference between the air and the land, that you could have a lot of, nearly flightless or semi-flightless birds filling those roles better than pterosaurs could. And maybe that's how they were able to get a foothold or something like that. Of course, there may also have been lots of other differences between pterosaurs and birds in terms of what specifically they could or could not do well. Birds, of course, are really unusual in having a wing that's formed from feathers. Pterosaurs do it in the far simpler to evolve, you would think, wing membrane adaptation. And there's a lot to be said for feathers. Feather wings are really durable things. They're easy to repair. They can take a licking, and then the bird can preen them back into shape.
And I mean, you cut the membrane of a pterosaur, it probably can't fly anymore. So that might have something.
Although I think we don't give the wing membranes of pterosaurs enough credit. We often conceptualize them as just being sort of stretched skin, and that's not right. There's a lot going on in a pterosaur wing membrane in terms of the muscles and the specialized fibers that are there. Pterosaur wing membrane would be a difficult thing to cut.
We do also have dinosaurs. I've seen paleo art of Yi Chi, where
Yes.
they've given it a wing membrane too. So
Yes.
is that the only member that we know of with a dinosaur with a wing membrane?
Yes, that's another independent instance of branch of theropod, branch of the Coelurosaur family tree that is experimenting, if not with true flight, with aerial locomotion in the form of at least gliding and parachuting.
Because it's not unusual to have like a flying dinosaur. I say flying, more like gliding, because you have like Archaeopteryx, you have all those smaller creatures, even Velociraptor to an extent. And is this what you're talking about?
Yeah,
Yes.
that's Yi. Yeah.
And even Velociraptor to an extent, it doesn't necessarily fly, but maybe declining down a tall thing, it can kind of glide enough to slow itself down so it doesn't just fall and hit the ground. I mean,
So the ulna velociraptor is known to have quill knobs, which confirms the presence of some sort of a long, complex arrangement of feathers on the arm. And of course, we know from other close relatives of Velociraptor, other raptors preserved in asphalt deposits in China, that they did have extensive fans of feathers on the arms and on the tail. How Velociraptor was making use of those structures, I don't know. Maybe it was using them to help it turn and maneuver. That's been suggested based on some studies, some behaviors that we see in ostriches. Maybe the raptors are using those as display structures, which is certainly a function of feather fans in a lot of ground-dwelling birds, peacocks, turkeys, sure. It is also possible, it's also been suggested that those may have been structures that were inherited by strictly ground-dwelling raptors like velociraptors from a at least semi-arboreal, possibly gliding, parachuting ancestor, something along the lines of Microraptor further back, something like Anchiornis, some sort of raptor that was hanging out there in the trees. That's a very controversial idea. I think it's right. I think our dromaeosaurs with their caudal rods and their feather fans do descend from an arboreal, a possibly gliding ancestor. But there's certainly no scientific consensus on that.
Because, I mean, raptors aren't the largest of creatures. They tend to be, I don't want to say smaller because Utahraptor and Deinonychus.
By dinosaur standards, they're small.
By dinosaur standards, they are fairly small creatures. So that would mean that they're not at the top of the food chain, to say. So, and even, I mean, what was that? Prehistoric Planet. They were showing how maybe the raptor, they're on like a cliff face or something. Maybe there's something down and just... It's the only real answer is we just got to find more stuff. I mean,
yeah, Velociraptor's got the feathers. It's got to be using them for something, because the evolutionary rule is use it or lose it. Big, complex, expensive structures don't just stick around for no reason.
Evolution is very precise in that sense. It's kind of the same reason why humans don't have gills and wings. I mean, we don't live in an ocean, so why do we need gills?
Yep.
And feathers being shown like that, and because have we found like Utahraptor with feathers on it, or do we know they? No.
No, we don't strictly know that Utahraptor has got complex feathers on its arms or on its tail. Animals like Velociraptor, and again other specimens from China, make us suspicious that Utahraptor did. But if you can evolve a fan of feathers, you can very easily lose a fan of feathers. Utahraptor is among the most terrestrially adapted of the Deinonychosaurs. So it would not surprise me to learn that the feather fans on the arms of Utahraptor are a structure that is greatly reduced or lost in that particular raptor. But for now, because we know animals like Velociraptor does retain the feathers, I think the most conservative choice on the part of a paleo artist is to draw them in, to include them. But, integumentary structures tend to evolve very, very rapidly because they don't interfere with a lot of the other mechanics of the organism. So you can make tweaks and changes to hair, to pycnofibers, to feathers very, very easily. It's one of the reasons why they become so specialized and develop so many bizarre display features in modern day birds.
I mean, you can even look at modern birds. Not all feathers are the exact same. I mean, that too. Even on like the same bird, it's not just a bunch of the same feather. It's each feather is very meticulously crafted.
Yes, the feathers of modern day birds serve many different roles, and there are many different kinds. You've got the downy feathers, you've got the true flight feathers, that are asymmetrical. You've got the contour feathers that just maintain the bird's shape in flight. And then, of course, you've also got my favorite feathers are the bristles, the tactile sensing feathers, the long structures that often are present across the beak and over the eyes.
And I mean, that alone would there's a lot you can look at there. I mean,
yes, we have no direct evidence for bristle feathers in any non-avian dinosaur, not yet. I bet you they're there. I suspect Utahraptor has big eyelashes like an ostrich.
Or like a secretary bird.
Mm-hmm. Mm-hmm.
Even there's still people who deny that T-Rex has feathers. Clearly, it wasn't flying. That we kind of knocked that off the block. I mean, if it was,
there's more used to feathers than just flight. That's probably not how they originated either.
If there is a T-Rex flying, that would be horrifying. But it probably would have more display feathers than feathers for like display, possibly getting a mate, maybe scaring other predators off.
You can invent lots of functions, and indeed evolution has stumbled across lots of functions for feathers. In the case of tyrannosaurs, of course, within that group, you expect to see some feathers present. That being said, of course, the skin fossils that we know of from tyrannosaurs don't show any sort of strong indication of them, but we don't have a very broad sample from across the animal. A major function of simple feathers is insulation, and you expect the need for insulation to diminish as an animal gets larger and as an animal lives in a environment that's warm all year round, in a hot, seasonally variable, at least in terms of temperature environment, just as you see in rhinos and hippos and Cape buffaloes and elephants, a dramatic reduction in the amount of hair.
So maybe younger tyrannosaurids tend to have feathers, and they lose them as they get older.
A small-bodied tyrannosaur, a young one that's got a lot of surface area relative to its volume, I would certainly anticipate having a more extensive coat of feathers than a really, really big adult, just as a baby Indian elephant has got a more extensive covering of hair than does a big adult.
You also see it in baby birds, too. Look at how downy and fluffy a newly hatched chicken or duck or any other bird is compared to their adult form.
And then
penguins.
I guess we don't really know if they lose the feathers completely or if they just kind of the feathers maybe don't grow in as much as they get older. Because I mean, the larger an animal, like look at sauropods. Sauropods, they wouldn't have feathers. That isn't.
Don't be too certain about that. Don't say that as an absolute. We've got sauropod skin, even baby sauropod skin from eggs in Argentina. And you're absolutely right. They don't show evidence of feathers. We've got no direct evidence of feathers in sauropods. But my worry is that feathers may actually turn out to be a basal characteristic way down there at the start of the dinosaur family tree. The genes for them may be present in sauropod dinosaurs, and although they may not have them for installation, I'm still not totally convinced that they wouldn't have feathers, simple feathers in the form of, again, say, eyelashes, the way Littlefoot from The Land Before Time. It's got eyelashes. Ahead of its time, The Land Before Time.
And, I mean, even like that, it doesn't have to be, it looks like a eagle or a hawk and it's covered head to toe in feathers. It can be smaller things. I mean, more like how like a rhino isn't like completely covered in fur, but it still has hair. Maybe something possibly like that. Maybe smaller body hairs that probably don't preserve as well.
Yeah, rhinos have got, very sparse hair covering. They still got some eyelashes. They still got hair coming out of their ears. They still got hair on the tips of their tail. You can imagine a sauropod maybe having proto-feathers for fly swatter, anti-parasite reasons. You can imagine them having them to help collect dust out of its eyes. A browsing diplodocid sticking its narrow snout into the prehistoric foliage, going after choice vegetation. Maybe it benefits from having some feathery bristles or whiskers to give it some extra tactile senses. Maybe. Again, no evidence for it whatsoever, but the absence of evidence is not the evidence of absence in this case, I don't think.
And also, there's a very clear feathers already don't preserve well. So it would be like plucking in hair from my arm versus a turkey feather. I mean, you could imagine which one preserves well for all you people listening. The one from my arm is going to disintegrate within a couple years, and turkey feather will probably last a bit longer. So
that does lead me to a question, because when we do find feathers on dinosaurs, it generally tends to be from smaller bodied creatures like Sinosauropteryx and such. Eutyrannus is the only exception of that rule I can think of.
There's some decently sized therizinosaurs as well. But yeah, Eutyrannus, great. Yep.
Yeah, but nothing like a large theropod-sized creature where we have found feathers that I can think of. Not like a tyrannosaur size or bigger.
Oh, well.
Yeah, there aren't very many candidates for that. So yeah, the thing that's going on there is, in order to get feathers preserved, you've got to be buried so quickly, and you probably also need to be buried in very, very fine sediments. And it's hard to quickly bury in very, very fine sediments a really big
large
animal. Think about what it would take to rapidly bury a sauropod, or a big, even animal the size of Triceratops, or the size of Tyrannosaurus, or a big megalosaur. It would just be an unusual set of circumstances. And then to also be lucky enough to last this long and for us to find it, not great odds. Now, it's happened. We've got really big duckbill dinosaurs. They're preserved with skin. We've got the great hadrosaur mummies. No evidence of feathers there. We've got one really great Triceratops mummy, the wonderful specimen that's on display at the Houston Museum of Natural Science. That animal does not display direct evidence of feathers, although it does have these strange, scaly goosebump structures that some people have suggested may record single simple filamentous, or where single simple filamentous feathers would have been anchored and extending from it. So even in those cases, we have some instances that are not clear.
Well, it's funny you bring up large theropod, well, not theropod specifically, but large dinosaurs that don't have feathers. Do we have any evidence of like Therizinosaurus or Therizinosaurida creatures? Because they're always depicted with some form of feathering.
Yes, we do. Not for Therizinosaurus itself, but from other Therizinosaurs from other members of the group in China. We do indeed have direct evidence of feathers. As a matter of fact, we've got evidence of different kinds of feathers, of all simple feathers covering the body, and then some specialized ones, long stringy ones towards the tail.
And I mean, they're not small they're not small creatures. So, well, some of them are smaller, but
that's right. And the thing is, the ones for which we've got feather evidence, direct feather evidence, are smaller representatives. Again, not Therizinosaurus. So when we illustrate Therizinosaurus that way, we are giving it an integumentary covering that is consistent with a smaller member of the group.
Genus, yes.
Maybe that's the right thing to do. Maybe it's not.
And for all we know, maybe it could be like the whole T-Rex thing. Maybe as it's younger, it has thicker feathers. Maybe this thing lived on a mountain somewhere and needed thicker feathers. Who knows? I mean, individual, and that's another thing. Every single individual different specimen is unique enough. The same way that maybe one person has a lot of hair, they got really long hair, another person is bald. I mean, how do we know?
Individual difference is something you do always have to take into account with paleontology.
Because, I mean, maybe one velociraptor was very feathers. Maybe it was very lucky and it got a lot more feathers than usual. And maybe one wasn't and it had a depletion of feathers. Maybe there's something wrong genetically there. I mean, they're all unique specimens. So, and it's a very unique thing. But I guess saying something like Velociraptor has feathers is just like an on average, they tend to have feathers.
It's certainly, I think, true to say that right now, where we've got strong evidence, the Deinonychosaur group is a group of feathered dinosaurs.
Specifically, if I'm not mistaken.
No, there's no direct evidence for Deinonychus or Deinonychus having feathers. I would be completely shocked if it didn't have them. Okay, the evidence really is very strongly that the whole group, especially at the scales of animals like Deinonychus, is going to be feathered, and that's the right way to go about depicting them. Jurassic Park and the Jurassic World franchise has got no excuse for not giving their raptors feathers. They absolutely should. My point with Utah Raptor was simply that whether or not the big fans of feathers on the arms would have been retained that far into a terrestrially adapted, large-bodied representative of the group sort of presupposes, I think, a little bit that those structures are not being used for sexual display and therefore would not logically be subject to extreme fluctuations in their presence or absence. Although if you put it to me and said, how do you want me to draw this Utahraptor, I would say, give its arms feathers. That's our best guess.
And I mean, these are mainly more later Cretaceous, well, not specifically later Cretaceous, but later on time period Cretaceous critters. I mean, things like Ceratosaurus, it's not usually depicted with feathers.
It's not. It's true.
But it's also not much taller than like a human.
It's also a more not primitive, I hate using that word, a more basal form. They are relatively close to their earlier ancestors and we're also dealing with the Jurassic period there too. So it might have been that it was just, you've got an animal living before feathers have evolved. At least the big, bright feathers that we're thinking of and talking here with like Deinonychus and Utahraptor and so on and so forth. And it could also be like, it is Ceratosaurus that we have evidence of osteoderms, right, Dr. Persons? Yes. So there you go. We've got an animal that just had evolved skin, and that was what worked best for that creature.
I think the question of should we be depicting Ceratosaurus with a simple coat of proto-feathers is a really fascinating question. It's not one for which there's anything close to a definitive answer. Ceratosaurus, as you say, is not a super huge mega theropod. It falls within the range for which we've got animals that do have simple coats of feathers. So the question for Ceratosaurus maybe relates strongly to just how far down the theropod lineage you want to hypothesize the origin of feathers. I'm inclined to say, yeah, Ceratosaurus should have at least some feathers on it. I suspect that by that point in time in the theropod lineage, feathers were present, but bear in mind, I think feathers may very well have originated at or even before true dinosaurs show up. Remember, pterosaurs have got simple integumentary structures too, so it's possible that the shared common ancestor of pterosaurs and dinosaurs already had them. We're in this interesting point in paleo art and our mental conceptions of dinosaurs, where the rule has been, the default condition has been for a long time that dinosaurs don't have feathers. And then when we find some that do have feathers, we immediately move to, okay, well, the ones that we know have got feathers have them. But it's almost as though I think we feel the conservative thing to do is to say a dinosaur is featherless until it's proven to have feathers. And I bet you that's the wrong attitude. I bet you the right attitude is, at least for theropods, they've got feathers until we've got strong evidence that that they lack them. That's my suspicion, because there's no real reason. I don't think there's any particularly good reason to assume the default condition is to lack feathers when we've got lots of instances where, when you have the right preservation potential to record them, you do have the presence of feathers.
I mean, we're talking about nodosaur, something like that, where maybe instead of a thick coat of feathers, it has osteoderms. Well, it definitely had osteoderms. We know that for a fact. I mean,
and we've got some good armored skin, some finer osteoderms off of, say, Borealopelta, that suggests, there's not room, there's not exposed skin for feathers to creep out of across the majority of the animal. Could Borealopelta and others still have bristle-like feathers over their eyebrows? Could they have had fuzzy armpits? Those are all possibilities.
And this is probably a weird comparison, but like Galiptodon, it definitely had like fur, fuzz, whatever you want to call it, hair. So
and a modern armadillo, even, which is covered up by osteoderms, they still got hair. Pangolin, it's still got hair.
And so, I mean, probably not on heavily the back of ankylosaurids where the osteoderms are. It probably wasn't like the osteoderms were covered with like a mat of feathers or something, but the underbelly, the arm part that's exposed, maybe the neck, maybe part of the face. There's
it's
a lot
possible
of that aren't.
Well, it's possible. Again, the large body ornithischians that we know of, that we've got good mummies for, including Borealopelta, but also including, of course, Edmontosaurus, Saurolophus, Regulosaurus, and now Triceratops, do not record skin pattern across the majority of the body that is consistent with the presence of feathers. So based on that, I would say I don't think an ankylosaur is going to be shaggy on the underbelly the way that Glyptodon is depicted. That would be my bet. I think that's the most likely scenario. But having said that, it's absolutely not the same thing as me saying that we know that we have direct evidence that wasn't the case.
And of course, other creatures, other species from the genus of ceratopsians and things like that. Because me and
the family of ceratopsians,
talking about this, how Pachyrhinosaurus,
I was going to bring that up, yeah,
is depicted with some, like the paleo art with like it having fur and stuff. What is the
woolly? It was a woolly Pachyrhinosaurus.
Is there like actual evidence behind that, or just something somebody did?
Well, there's no direct evidence of a dense feather covering for Pachyrhinosaurus. Having said that, that is not a random decision. It isn't that people just pick Pachyrhinosaurus and say, hey, the name sounds like woolly rhino, let's make it woolly. The idea there is that Pachyrhinosaurus is ceratopsian for which we have an extreme northern range. You can find them up all the way into Alaska. Well, Alaska is a lot warmer back in the Cretaceous. This is still an animal that would be hypothesized to live in some at least seasonally cold, seasonally chilly environments, where if it were a mammal living at those same temperatures, you would anticipate it to have some level of insulating hair, of insulating fur for that purpose. And if we suppose that that ornithischians have got the genes coding for feathers, it'd be reasonable to expect that could coat like that could evolve relatively quickly. So if you wanted to pick one ceratopsian that did have a more extensive covering of simple dino fuzz or feathers, Pachyrhinosaurus is probably the best one to pick.
And especially since it lives in a seasonally cold thing, there is a chance for it growing and shedding. So, I mean, even like elk in Alaska, it's not, depending on where you are in Alaska, I'll say that. Southern parts like Anchorage, if you go in the summer, some of the elk and moose and bears like that, they kind of they lose a little bit of it because they don't need as much. But in the winter, they definitely grow it out. So, especially with Pachyrhinosaurus, I mean, there's a chance that maybe if it gets colder out, it grows a bit more something than basically peach fuzz.
Yeah, if it had fur or hair like it does depicted here. Now, I personally think that the amount of wool or hair that we tend to put on Pachyrhinosaurus in artistic depictions is a bit too much. The main thing that I did want to add to this part of the conversation was that possibility does not equal probability, and especially with the woolly Pachyrhinosaurus, this is like the textbook example of what I'm talking about. People will sort of push the boundary. They're not doing it in like a antagonistic way or anything like that. But in terms of like the very nature of our science and our discipline, we have to sort of throw out these wild guesses just to get conversations started. Like the very fact that we're having this discussion, I think would make Mark Whitten very, very happy, and that he succeeded in his goal of like trying to figure out, okay, well, what's reasonable for this animal? Let's debate and let's talk about it. However, if you're a layperson who does not know as much about like the intricacies behind paleo art and just how much of it is estimation and guesswork, you're going to take a look at the woolly Pachyrhinosaurus art and go, oh, I guess they really were woolly because this is in a museum, it's on display. You're going to take it at face value and go forward with it from there. But that's the one area where I have a problem with it. Is sometimes people confuse what's very speculative with hard fact.
And paleo art in general is very unique in that sense.
Yes.
Because other art, like, oh, I'm going to draw a picture of the Eiffel Tower. You can just go to France, look at the Eiffel Tower. You can look up a picture of somebody who did the Eiffel Tower. This, you're like, I'm going to draw a Pachyrhinosaurus. There's no pictures of Pachyrhinosaurus. It's basically completely guesswork.
Not completely. There's a lot of science that does go into the artwork itself. But
like outside of like actual fossil evidence that gives you the base structure in what you're working with, most dinosaurs we don't know the color of. We don't know whether it actually did have some form of hair or not. We didn't know if maybe it had some weird soft tissue thing hanging off of its body.
Mm-hmm.
I mean, for all we know, there could be some like weird soft tissue bubble on its nose.
My sort of standard here has always been kind of like what we use in the court system. Like if you're going to put it in a museum, I think it should be beyond reasonable doubt. Like there's nothing in paleontology because we're essentially doing forensics. I feel like it should be something that we can say, yes, we're very confident that A is B and B is C, you know? No, that doesn't mean that I think that we should get rid of speculation at all. I think it's extremely important for the science. But when it comes to like public outreach and discussing things with common, I don't want to say common people, that makes me sound like some sort of lord or something. But when you're discussing things with people who have not probably learned about dinosaurs since they were in the 4th or 5th grade, that's sort of what I focus on, is like what we know with a really good degree of certainty.
And that is a little bit of that, because, I mean, there is still a lot of speculation behind every depiction of dinosaurs.
That's true. And in this case, I would point out that making Pachyrhinosaurus completely fuzzless, that is, making it totally scaly, is also an act of speculation. Yes. Just because that's the traditional way of doing it doesn't mean you as an artist aren't making a choice, that you also aren't speculating, that you also ought not to be held accountable for defending your decision about what sort of integument or lack thereof to give it.
Because I mean,
that is a very good point. I tend to focus too much on the other end, but the sword also goes both ways there.
Oh, absolutely.
And there is a part of me that sadly believes that we probably in this lifetime will not get a 100% accurate depiction of like T-Rex. Sinosauropteryx, yeah, probably. I wouldn't doubt that we get an actual like just basically photographic look thing of that. I mean, we already know the color.
We got Psittacosaurus nailed down pretty well too.
I mean, but like T-Rex, the most famous dinosaur out there, just probably by fact. I don't think that in this lifetime we will get an actual 100%. This is definitely what it looked like picture.
Well, we'll never get 100%, and certainly we don't have 100% for any dinosaur. And I would point out to you that perhaps just as lamentable as not knowing what 100% of dinosaur looked like, you also won't know 100% what a dinosaur behaved like, which I think is just, if not more, interesting. But I wouldn't count you out on the Tyrannosaur front just yet. Remember, we've now got mummies, dinosaur mummies of Edmontosaurus. We've now got a dinosaur mummy of Triceratops. And although we don't have what I would classify as a dinosaur mummy for a Tyrannosaur, we do have probable Tyrannosaurus skin fossils preserved. And the rate of dinosaur discovery is increasing at an accelerated pace. More people studying dinosaurs now than ever before. More dinosaurs are being dug up every year now. And for that reason, I think the preservation conditions we know are out there. If we can get, and hadrosaurs may have a number of things going for them, but if we can get a mummy of a Hell Creek duckbill, a Hell Creek ceratopsian, somewhere out there, there's a Hell Creek tyrannosaur that's preserved in a mummified state. And it really would not surprise me at all if such a specimen is found within your lifetime. Heck, I think I got a good chance of seeing it at some point myself.
And especially comparing it to Edmontosaur and Triceratops, because a lot of depictions show Tyrannosaurus, because they wouldn't go after the big old healthy giant in its prime Edmontosaur. It's like, no, I'm not. That's how most predators work. They don't go for the big old healthy adult. They go for the child, the grown up, the old one, the sick one, the one that's lagging behind. So we always get this depiction of it hunting smaller Triceratops, smaller Edmontosaur, but Edmontosaur and Triceratops at max can rival Tyrannosaurus in size.
They certainly rival Tyrannosaur. Triceratops certainly rivals Tyrannosaur in terms of danger. You have to be a pretty desperate, a pretty hungry Tyrannosaur to tangle with the Triceratops. Now, it happened. Absolutely, it happened.
Definitely.
And the horns of Triceratops are there, I think, in large part to ward off attacks from big theropods. A big, healthy Edmontosaurus, if you're an Edmontosaurus, you can break a Tyrannosaurus leg with a good, swift backwards kick, just the way a zebra can break the face of a lion with a backwards kick. Duck-billed dinosaurs don't have a lot of defenses, and I think mostly they're surviving by being alert and having better endurance than Tyrannosaurs do. But a big healthy adult Edmontosaurus is still really, really dangerous game to tackle. Now, maybe that danger level goes down dramatically if you're a Tyrannosaur that's got some level of cooperation. If you've got a partner to help you on that.
Get one to distract it while the other one tosses it to the ground or whatever. I mean, so that goes on to like pack hunting and things like that. I mean, do we have any like actual evidence of Tyrannosaurus being like a pack creature? Or
Michael knows this. He's taken my class. What do we have for Tyrannosaur, broadly speaking, evidence of social behavior, Michael?
The exact name of the site escapes me at the moment, but we do have a amazing site in Alberta, Canada, of Albertosaurus remains.
It's just called the Albertosaurus bone bed.
Oh, perfect. I love it when things work out. And it's a fascinating site because it's around 20, 25 individuals.
At least confirmed, yeah.
Wow.
Yeah, 20 to 25 confirmed Albertosaurus individuals, all of completely varying ages. You have very, very young ones, you have very, very old ones, and everything in between. So you have a large group, I argue like a big family pack, all working together, operating together. And now, granted, we don't know for sure if I believe the term is Grex, when you have a pack of Tyrannosaurs.
Mm-hmm.
That's awesome.
Now, Dr. Persons makes a really good point whenever this site is brought up or teaching about it. And it's a comparison to modern lions. So I'm going to give it over to him on that regard because he can explain it a lot better than I can about the size might vary for packs or Grexes.
Yeah. So the point I make, number one, is that Tyrannosaurus is a big group. Lots of different genera and species in it. It's a bit like saying cats, right? Some big cats, lions, highly social. Some are total loners, leopards. Some are intermediate. But the point for the Albertosaurus bone bed, the thing that intrigues me is there are just so many individuals there that doesn't seem like you've got the optimal number for hunting. It seems like you've got way more than that. Now, maybe that means we don't have a normal social group. Maybe we've got these animals coming together for some
like
other
a
reason.
Breeding grounds kind of thing, maybe.
Something like that. Who knows? That's not super common in big predators, but maybe. But if indeed we do have a social group, and we do have variability in ages there, so it does sort of look like the composition of a social group. If that's the case, we might have a situation that we sometimes see crop up in prides of lions. In the Ngorongoro crater in Tanzania, which is this huge volcanic caldera miles across, water pools in the center year-round, so it escapes the dry season. And that means that herbivores will hang out at this site year-round. And that makes it, in the broader Serengeti ecosystem, that makes it prime hunting real estate.
Definitely.
And there you've got lion prides that are just huge, that are way bigger than the optimal number. But the reason you've got these groups, and the pride is a related group, a group of individuals that share genetic material, and therefore individuals that benefit from a little bit genetically from the survival of the lions next to them. Way bigger than is optimal. You do that not so you can hunt, you do that so that you can defend, so that you can defend that hunting ground against other rival prides. In effect, what you have is a lion army or a lion gang. We've yet to see this depicted in Prehistoric Planet or Walking with Dinosaurs, but I think an incredibly dramatic prehistoric scene that may very well have played out is a clash of Albertosaur, a clash of Tyrannosaur prides or grecs on the scale of rival armies, numbering into the 20s or even 30s of individuals. That would be a cool showdown.
Has anyone looked at the older members, would be my first guess, to see if they have any Albertosaur pathologies on them?
Oh, that's a great question. So first off, we struggle a little bit because the bones are jumbled up. Although we can get a minimum number of individuals and say something about the range of sizes, it's hard to actually piece together specific skeletons. But every big Tyrannosaur that's been found records lots and lots of injuries. There are some injuries that have frequently been interpreted as Tyrannosaur on Tyrannosaur violence. There's suggestions of face biting. There's the Y-Rex Tyrannosaurus specimen at the Houston Museum, where the tip of the tail seems like it may have been actually bitten off. And the only really good candidate for that, bitten off late in life, would be another large adult Tyrannosaur. So we do have some potential evidence of Tyrannosaur fights. It's a thing that did happen.
And just because something lives in a pack doesn't necessarily mean that it hunts in a pack.
Sure.
They could live in a group, and 1, 2, 3 could go out, hunt for stuff, maybe bring some back, maybe just not. I don't know. So, I mean, there's a lot there. They might use the ground collectively. They might have a mutual understanding. That doesn't necessarily mean that they hunt in packs.
Yeah, that is why in part Phil Curry applied the term grex to a Tyrannosaur group, because a grex simply means it is a gregarious group. It doesn't have the same connotations of pack or pride or clan, of sophisticated internal social structure, or of cooperative hunting. It doesn't rule out that possibility, but it doesn't strictly imply it.
Does lead me to one last question regarding this issue, and again, continuing with our lion comparison. I know that the female lions are always the one that go out and do the hunting. Is it, when it comes to lion packs going out to hunt, how many members of the pride are going out, if you know off the top of your head?
That's variable, and I don't know off the top of my head. I suspect it very strongly varies with the kind of quarry that you're going after.
Good point.
There are, we do have documented instances now of lions going elephant hunting at night, and they basically do that in one big swarm that attacks the elephants from the rear.
We're making the comparison to lions, but even, I don't want to say keeping it in North America, because we did have lions in North America, unironically. Technically, we still do, mountain lions, but big cat. Like wolves, they live in packs, they live in groups, they live in, I was about to say herds, but they don't live in herds, they live in packs. But they live together. But it is often observed that they will hunt alone. That they will take down moose, elk, bison, etc. Whatever they find alone.
So wolves have got great flexibility in terms of their behavioral repertoire. Certainly, they can hunt, and frequently do hunt, in very organized fashion. But of course, you don't necessarily need a big group for everything that's on a wolf's menu. If you're going after rabbits or something smaller than that.
So, I mean, maybe not necessarily with just larger theropod creatures, maybe smaller ones.
Yeah, the other
We were talking
comparison
about
there
raptors.
is with like coyotes and cheetah. They're extremely variable in terms of being social or asocial. Oftentimes, a cheetah hunts totally by itself, but there are cheetah consortiums where you have groups of usually closely related males that do hunt in a very cooperative, fairly sophisticated manner. Coyotes can be similar, nowhere near as well organized, as social as a pack of wolves, but nowhere near as asocial as, say, foxes. And those are very, very closely related species. And this is because, behavior is also something it's extremely flexible in terms of evolution. So when we talk about raptors are pack hunting animals, that's probably wrong to say as an absolute.
I
Some
mean,
raptors are pack hunters. Some raptors were probably loners, just as some cats are, just as some canids are. Undoubtedly, that's true for tyrannosaurs as well. And when we're talking about tyrannosaurs being social, we're not necessarily talking about T-Rex or about Tyrannosaurus.
and even within T-Rex, maybe after like reproducing, after breeding, after whatever, a mother might stick with her young for a very long time. So you might get a pack of 2, 3, maybe even 4 T-Rex, and it's just a mother and her children.
Our
That,
evidence for parental behavior in tyrannosaurs is very limited, but I would be shocked. I really would be shocked if it turns out Tyrannosaurus wasn't a good mom. Lots of birds are great moms. Crocs and alligators can be good moms as well. They can defend the young. I would be really surprised if a big tyrannosaur didn't leverage, if a big mother tyrannosaur didn't leverage her bulk, her power, her ferocity in a maternal manner.
and I mean, because we don't know, but some sauropod species kind of lay their eggs and just leave. That's always
They
a big
seem to
issue.
have. They seem to have. It's unclear to what extent that's true. Certainly, it seems like with some of the big nests in Argentina that this wasn't a place where the adults were hanging out on the nesting grounds. That could be extremely dangerous. That doesn't necessarily mean that the adults weren't still in the area or that the young did not go and rejoin the herd. Um, it's hard to sort of envision what that would look like for fear of a mother sauropod squashing the young. On the other hand, sauropods lay so gosh darn dang many eggs
Maybe it's like a
all
turtle
at
thing.
once that they could probably afford to squash a few here and there.
I mean, it could even be like a turtle thing where at some point they either turtles don't usually live in groups.
Same exact strategy. Yeah, it's predator satiation.
Lay 100 eggs, one is bound to survive. I mean, and one sauropod is massive enough, so even because triceratops are actually surprisingly lone wandering creatures.
We don't have the massive triceratops bone beds that we do for centrosaurines. So Centrosaurus, Styracosaurus, Pachyrhinosaurus, those are all known from pretty big bone beds. We do have some evidence that Triceratops at least hung out in small groups, but for the most part, Triceratops seems to be a loner. Exactly.
And I want to say the largest Triceratops group that we have found has been 5, 4, 5-ish, 4. Mm-hmm. And so, I mean, to say that all ceratopsians don't live or are solitary creatures would be a lie too. I mean, Pachyrhinosaurus, Styracosaurus, I don't know what I'm trying to say here. They did live in larger groups, and Triceratops is on the larger end of ceratopsians.
Oh, absolutely. Yeah, Triceratops is basically as big as it gets. It's rivaled a little bit by Torosaurus, Titanoceratops, but it's basically maximum size for a ceratopsian.
And so smaller creatures like Styracosaurus and Pachyrhinosaurus, where they are smaller ceratopsians, live in larger groups because they are smaller, so they're more easy to take out, per se.
Yeah, those ceratopsians also belong to the centrosaurines, whereas Triceratops is a chasmosaurine. And there is actually some evidence to suggest that along those group lines, you have this division in social behavior, because in places like Dinosaur Park, where you've got centrosaurines and chasmosaurines preserved in the same fossil beds, we find the chasmosaurines generally all by themselves, not in monodominant bone beds, and we find the centrosaurines all together. So, within our derived ceratopsids, there does look to be this sort of difference in social strategy.
And there was, I would never be able to find it again because it's lost in the ether. I saw something about like humpback whales. They occasionally have a fly in here. It's getting annoying. They occasionally save smaller animals from predators because they do that with their young and things like that. Could that possibly be true for like sauropods? Because
You mean, do we imagine a sauropod standing up for a baby stegosaur or something like that?
possibly,
Stepping in to defend it? Well, that would make for a lovely kids television show. It could certainly happen by accident. I could see as scared small-bodied ornithopod, Drinker, something like that, being chased by an allosaur and running right into the thick of a sauropod herd for protection. That seems like a pretty smart move to me. Whether or not, if we imagine, I suppose, let's suppose sauropods do have a maternal instinct to defend their young and to defend other members of their herd. Could a small-brained sauropod, for a moment at least, mistake or transfer that sort of instinct to a small-bodied, distressed stegosaur that's being bullied immediately nearby? Could that click on and the sauropod's whip-like tail come in to save the day? Sure, it could happen. Why not?
The other thing to be aware of here is that you're also comparing humpback whales, which are very social mammals and like so socially developed. I think you can make a good argument they're almost, I don't know, like there was that new paper that came out where they've like started to crack sperm whales and how they're communicating with each other. And like humans are in that same thing. We're very social creatures, and we also we all have pets. Dr. Persons is a very, very avid dog fan. I am a cat person, always have been, always will be. And I love my cat. I love my cat to death. I know that feeling doesn't extend back to me, but it's like, people call them fur babies. And from an evolutionary perspective, I've seen it said that like the reason that humans tend to like really get attached to their animals and empathize with even like a rabbit that you see in the wild, something like that, is because that's from our instinct as a social creature. We need to protect our young, even if they may not be like our children. If you're in a tribe with a bunch of other cavemen, it's like they're still part of your tribe. They're your people. I'd argue that whales might have a very similar phenomenon going on. We've seen them grieve. We know they can mourn for other animals, at least within their own group. So there might be something there. These are also the same creatures that are known to use pufferfish as drugs. So it could go both ways there.
Yeah, if we imagine the whales doing it because they're so socially sophisticated and so darn smart, I was suggesting there might be a scenario where the sauropod would do it because they're so dumb. Either way, though, it's still a great sequence for a TV show.
And I mean, even to an extent, sauropods are very social creatures. They're always
Some of them.
depicted-
Careful now.
Again, some of them. They're shown in large herds. They're shown traveling together. They're shown kind of sticking together. The Mother's Day site is a possible flood site where I think Diplodocus might be a potosaur. I'm gonna go with Diplodocus. That seems about right. I'd go back and now I'm thinking about that. I'm gonna go with Diplodocus. It might be dwarf Diplodocus or some kind of juvenile Diplodocus. They were in a large herd whenever it flooded. So I mean, clearly there is some sort of, maybe not whale, but more like bison, maybe even elephant-like, maybe kind of herd.
You don't have to be super smart to live in a group. It may very well be the case that being a social animal in many instances encourages the development of intelligence. Maybe that's because it puts an emphasis on behavioral flexibility. Maybe it's because you get benefit from keeping track of sort of ranks within the social group. But you don't have to be super smart to live in a big group. Lots and lots of fish live in very, very large groups. So maybe instead of thinking about big groups of sauropods as being like whales or elephants, think of them as being like tuna and sardines.
That is a fair comparison. I mean, it's already hard enough to take down a sauropod, so a herd of like 60 of them, you come across that, it's a drastic number. Predators probably will be like, oh yeah, no, we're not messing with that.
If I were to make a comparison to like what social mammal might be most closely resemble what we see with some sauropod groups, it would probably be zebras.
I was about to say
zebras are everyone's in the same group, but for their own protection. If one zebra dies, the rest aren't generally going to go out and save the other zebra.
Every zebra for themselves to an extent. Whenever a lion comes and attacks a zebra or there's a gator, they don't stop and help the one zebra. They all just scatter. I mean, not to say that sauropods will scatter like that specifically, but maybe they don't quite, like the one that lacks behind. They're just like, all right, we're leaving that one behind. It's too weak to carry on. We're just gonna
careful now. There are lots of equine lovers there on the internet. You're going to get letters.
Especially in South Carolina.
But I mean, specifically to stay in a herd for better protection. I mean, you see it with hadrosaurs and things like that. Sauropods' defense is their size.
Mm-hmm. Yes, that's definitely a major defense. Some of them have got a few other tricks up their sleeves too. Some of them, of course, have got tail clubs. Some of them have got
Saltosaurus, not Majungasaurus. That's their
hook-like tails. Yeah,
Mamenchisaurus. That's what I meant to say. Some species of Mamenchisaurus have tail clubs. I mean, and of course, Saltosaurus has osteoderms. So
lots of Titanosaurs have got osteoderms. Lots of them do.
But they are. Some are very social creatures. Some probably aren't, and that also could play into the size of the creature. I have no idea. I mean,
definitely a sauropod's first line of defense is just its bulk.
I mean, it's putting something like Allosaurus. Allosaurus is a very large predator. Something like Ceratosaurus or something against Brachiosaurus or Apatosaurus or Diplodocus. It is a very. It would be like a man trying to wrestle a bison. And that's also
Deterrent.
why
That's the main defense there. It's just how big they are. Most animals wouldn't even bother.
and you could see the species of the creatures around it: Ceratosaurus, Allosaurus, a lot of Carnotaurus-like creatures, Rugops. They're not tackle their prey, kill it, then eat it. They're skin grazers. They just rip some skin off the side, eat that, and then come back later, rip some more skin off the side, eat that. They don't necessarily kill the creature.
We really don't have a sense for what the hunting strategy of something like Carnotaurus is, what those Darnabellosaurs are up to. What you've described there has certainly been proposed. It may also be that animals like Allosaur or big titanosaur hunters, like some of the Carcharodontosaurs, Giganotosaurus, etc., may have been specialized for lunge and slash attacks, opening their mouths very, very wide, swinging the head down like an axe, going for the underbelly. Now, whether or not they were just sort of harvesting slices of sauropod flesh, and then it would sort of grow back, as some people have proposed, that seems a little far out there to me. But I do think that those predators have got probably a lunge and retreat strategy. Now, whether or not that was lunge and retreat long enough for the thing to bleed out, or lunge and retreat and return to strike again. But you don't succeed by tackling and grappling a sauropod.
No, the old, you mentioned it earlier, Walking with Dinosaurs thing, where it shows the Allosaurus jumping on the side of the. I don't know about that specifically.
It's great TV.
That's an attempt to make use of the Allosaur's arms, because you've got to get so close. You've got to really, really hug and chest bump the animal in order to use its arms. And to be fair, Allosaurus has really scary meat hook arms. They're not slashing claws. They're hooking claws. And the arms are quite strong and impressive. But it's really, really hard to visualize how an Allosaurus is using those claws to actually help it prey on something, because there's nothing it can grab with those arms that isn't theoretically already halfway down the animal's throat. I don't fully understand how an Allosaurus is using its claws. Maybe it's just using them to transport big hunks of prey. Maybe the arms are strong, they grab a hold of something and they can carry it back to their lair or something like that, the way a leopard will carry something up safely into a tree because it's scared of the other predators in the environment. I don't know.
And it could even just be for smaller creatures. Maybe it surprises the Allosaurus, gets right on top of it, it can just grab it, kind of hold it down.
Maybe if you're an Allosaur, I don't know why you bother to grab something with your hands when you can go ahead and grab it with your mouth. I just don't know. And it's very, very hard to depict. And paleoartists have been struggling since the time of Charles Knight to get the Allosaur's arms involved in the activity, because they're so strong. They really do look formidable when you look at them by themselves. When you stick them up there on the animal and you try to model out how it goes, it becomes difficult.
Allosaurus,
probably a PhD thesis to be made just on Allosaur arms alone.
And Allosaurus specifically are one of, I don't want to say one of the few, the vast majority of dinosaurs have pathology on them, but they tend to have a lot of pathology on them.
Sure, I think that's really generally true for any large-bodied theropod dinosaur. If you're any critter that makes a living by routinely attacking multi-ton herbivores, you're gonna rack up the injuries.
And especially if they did hunt pods, they're bound to get knocked around a bit. They could definitely take a hit if they're hunting sauropods. And that's to say, for most creatures that hunt something that big, they got to be built to take a hit. Maybe the arms aren't necessarily even for other creatures. Maybe it's to hook onto the ground or something, maybe to kind of help pull itself up onto something.
Well, that's what they're sort of trying to depict in Walking Dinosaurs, and what other people have suggested is that we use the arms to clamp on to the side of a sauropod or something like that.
Not even in that sense. Maybe if a sauropod knocks it over, it can use its arms to help itself get up and recover quicker.
Sure, that doesn't explain the hook nature of the
That
claw
is
itself. But yeah, you certainly might think an allosaur would have an easier time righting itself after a tumble than would, say, a tyrannosaur. Although I think we underestimate a tyrannosaur's ability to stand up without its arms. An ostrich has got no problem rising.
That's true. But I mean, if you also flip an ostrich on its back,
yeah,
that is another thing. I mean, not saying that. Well, no. I definitely think a Triceratops could knock a T-Rex on its butt. So,
Oh, sure.
without a doubt. But I mean, that also goes back to the Jurassic is a very different time period than the Cretaceous.
Mm-hmm. And within the Jurassic's a big expanse of time. Cretaceous is a big expanse of time. The classic Jurassic that we think about is represented by the Morrison Formation when we're talking about Patasaurus, Diplodocus, Allosaurus, Stegosaurus. That's what we're talking about. But that's just a thin slice in one particular place within the period.
I mean, you can see the very similar body builds of theropod dinosaurs. I don't want to say that they didn't change, but like the general body structure didn't change a lot.
Well, within the Morrison, we see the arrival of allosaurs, which I think is really, really fascinating because allosaurs are, in important ways, very different from the theropod lineages that came before them. Yeah, in general silhouette, they look pretty similar to, say, megalosaurs. But they've got proportionately longer legs. They've got a much stiffer tail. Their arms are radically different. The way that their mouths function, the way that their necks function is different because they've got this really wide gape. They don't have particularly big, scary teeth, even. They don't have the big tooth serrations of a Morrison megalosaur. I think allosaurs are doing something different from those other theropods. And
Definitely.
Ceratosaurus, although we sort of label ceratosaurs differences, this is a problem of some biomechanical studies, in particular considerations of theropod dinosaur tails, which I care very much about. We label a lot of the traits of Ceratosaurus as being primitive or basal, and that's not right. I think Ceratosaurus has got some key specializations to it. It has got a really long tail and a really, really complex tail, really deep chevrons, consistently broad transverse processes or caudal ribs down the tail. Of course, is the only theropod that's got big, well-developed osteoderms. It's got the big horn. It's got the longest teeth relative to the size of its skull of any dinosaur. Tyrannosaurus got really big teeth too, but Ceratosaurus got really, really long ones with really fine serrations. Ceratosaurus also has very short legs. Allosaurus can easily outrun, even a big allosaur can easily outrun a ceratosaur. So
Allosaurus
Allosaurus
was definitely, it would, if it saw Ceratosaurus, it would probably hunt it. It would take it out and it would kill it and it would eat it. I mean, it's not outside of the realm of possibility. It seems like a very...
I would think that could happen the same way that a lion will attack a lone hyena, or at least, if not, try to fight it outright because it's dangerous. A healthy Ceratosaurus is dangerous.
Ceratosaurus isn't a pushover, but
chase it away. Yeah,
it's one thing to fight other herbivores to survive. It's another thing to go after another animal that is also adapted to hunt and kill things.
And it's also just sheer size alone. Allosaurus is much larger than Ceratosaurus. That is very prominently shown. The same way that Edmontosaurus towers vastly over like a Pachycephalosaurus. Maybe not that drastic, but in general. So it's not outside of the realm of possibility that Allosaurus, if it had to, would hunt Ceratosaurus, would kill Ceratosaurus. And
It must have happened. And I bet you adult Ceratosaurs often killed baby Allosaurs.
oh, definitely. The same way like wolves will kill baby cub bears if they're alone. I mean,
And Torvosaurus was eating all of them.
but
Sorry,
like
I'm partial to megalosaurids.
so that's not a very outlandish thing to say that like maybe younger Ceratosaurus, maybe even some adult Ceratosaurus would actively avoid Allosaurus.
Oh, absolutely. Yeah.
I mean, the same way that like not even the same time period, but if there was a Utah raptor with Tyrannosaurus, it's not going to go face with Tyrannosaurus. It's not going to go head to head with the Tyrannosaurus. It would probably lose. I mean, and they will tear each other apart pretty good, but the Tyrannosaurus in the end would probably, just out of sheer size alone, scare the Utah raptor away. I mean, so it's not outlandish to say that any significant drone. Well, I don't want to say significant, but is there any significant fossil depiction of Dromaeosaurus in the Jurassic?
Oh, that's a great question. So in the late Jurassic, yes, we do see Deinonychosaurs show up.
Coming.
So there are raptors in the Jurassic. Yes. And there is a case where the presence of raptors in the Jurassic has been known about for some time based on the fossil shed tooth record, but only relatively recently have we gotten good, extensive skeletal fossils of them. But yes, there are raptors present in the Jurassic. They're small, but they're there.
So could Ceratosaurus happen to fill the niche of larger raptors for its time? I mean,
well, I suppose in a broad sense, as not the biggest carnivore in the environment, it's potentially filling that role. But Ceratosaurus is in many ways, I think, the opposite of a raptor. It's got, again, very short legs. It's not very fast. Its teeth, its jaws are its major killing weapon. It has been suggested, in fact, that a ceratosaur may have been specialized for swimming. Big muscular tail like that. It may have been very good at it. We know from Spinosaurs that reduction in leg length is something that often shows up in animals as they get better and better at swimming. There's no really compelling evidence for it, but ceratosaur shed teeth have been shown in a study to correlate with where you find teeth from big lungfish. So there's some evidence to suggest that within microhabitats throughout the Morrison Formation, ceratosaurs are more associated with the wetter environments than they are with the broader savanna-like environments of the Morrison. So maybe ceratosaurus is doing something totally different.
You mentioned Spinosaurus and like leg reduction. I mean, I know there's more croc-like dinosaurs like Irritator and Suchomimus and Baryonyx and thing. Was there like a major one of those in America?
No, not yet.
Or North America.
Not that we know of.
So maybe that is the niche that maybe we're looking at it. I mean, Ceratosaurus is that kind of niche that it fills. I mean,
maybe, of course, the mouth of Ceratosaurus is way different. But
that is for sure.
But you can hunt aquatic prey in different ways. And I'm not suggesting Ceratosaurus was nearly as specialized for aquatic prey the way that Spinosaurus is.
And maybe Ceratosaurus is kind of that first step into that, maybe. I mean, but
if there's aquatic prey out there, it's reasonable to suppose a dinosaur specialized for it. But there's more work that needs to be done. I would love to see a good isotope study done on the
Oh.
teeth of Ceratosaurus compared to allosaur teeth and to megalosaur teeth too, if you can get the sample size.
So I think we need to start wrapping it up. But
Sure enough.
I mean, I'm sure y'all are very busy down there, not up there. Forget where I'm at sometimes. So I'll let y'all go, and I'll wrap everything up. And I hope
Okay,
y'all have a
that
wonderful
sounds
day.
good.
This was a lot of fun. Thank you very much for having us.
Of course. And
Yeah,
I'm
thanks
looking
for
forward
having
to
me
seeing
back,
y'all again.
and we'll see you in class.
And definitely. And for everybody watching, I'll tag the first interview with Dr. Persons somewhere along the video. I'll probably do it at the beginning. Makes sense. But I hope y'all have a wonderful rest of your day. It's like
You as well, man. Take care.
All right. Yeah.
And I'll see y'all later.
Adios.
All right, that was Dr. Persons and Michael Wellington. Not really prominent on social media, no offense to them. If you want more from me, though, I will definitely make a post about this. I'll probably make a few reels out of this. Go check out my Instagram, Prehistoric Life Podcast. And I'll definitely have tags for at least Dr. Person around. I already do somewhere on the mini posts I've made, but if you're interested in that, go see them out. He has a website. Just look up like scottpersons.com.edu. You'll find it. You'll be able to find it if you care enough. And if you want my content early-ish, sure. I try to post 2-ish days early on my YouTube, not Instagram. And if you want all of my content in one place, go check out my website, prehistoriclifepodcast.com. From there, you can get to my YouTube and my Instagram, and you can see all of my episodes actively on there. But other than that, a quick word from our sponsor. Take it away. I actually made a post about this, well, I guess the day of recording this, but pish posh. Take it away, advertising Eric.
Thanks, Podcast Eric. Now let's talk about today's sponsor, Dinosaur Trips. If you love looking at these amazing creatures that I show you, and even talking about these amazing creatures that I talk about, and you want to go see them in real life, I heavily suggest you look at Dinosaur Trips. Dinosaur Trips, created by Zach, gives you behind-the-scenes in-look at museums, and he even takes people out to digs. So if you sound interested in that, go to www.dinosaurtrips.com and tell them that Prehistoric Life sent you, and they will give you $250 off your tickets. And here's their Instagram if you're interested in giving them a follow.
That was the advertisement. So signing off, I'm your host, Eric Crawford. Come back for more dinosaur content. May have a few co-hosts coming up. We won't talk about that until then. But till next time, remember, keep it prehistoric. Bye.